Welcome to the presentation of high-level design for a chat application. In this presentation, we will cover key aspects of real-time messaging, notifications, message storage, and other important features that make a chat application scalable, efficient, and secure. Let's begin with an overview of the chat application. The application will consist of several important components: real-time messaging, notifications for new messages, message storage, user presence features, security and privacy measures, and scalability and performance considerations to handle millions of users. Moving on to functional requirements, the chat application must support real-time messaging, allowing users to send and receive messages instantly. It should handle one-on-one and group chats and track message statuses like sent, delivered, and read. Notifications will be sent both in app and as push notifications for new messages, even when users are not actively using the app. For message storage, we need persistent storage for text and media with encrypted storage to maintain privacy. Additionally, user presence features like online offline store status and typing indicators are crucial for real-time interactions. Let's look at the non-functional requirements. Scalability is a key concern, as the system must handle millions of users with efficient partitioning and sharding of messages to maintain performance. Latency is critical for a good user experience, so real-time messaging and instant notification delivery must be prioritized. We also need to ensure high availability with redundancy built into the system to minimize downtime. On top of that, the system should adhere to strict security and privacy standards, including end-to-end encryption and authentication protocols. Next, let's dive into the system components. The client side, which could be a mobile or desktop app, will display messages, cache data locally, and manage real-time communication with the server. The backend server will handle REST APIs for user management, WebSocket connections for real-time messaging, and a notification service to push alerts. A message broker like Kafka or RabbitMQ will decouple the sender and receiver for efficient message delivery. The data layer includes user and message databases along with cloud storage for media. For real-time communication, we will use WebSockets, which provide a full duplex communication channel over a persistent connection. This allows the client and server to exchange messages instantly. As an alternative, long polling can be used when WebSockets are unavailable or unsuitable, ensuring that the system remains resilient and functional. Here's a high-level overview of the data flow. When a user logs in, they authenticate using OAuth or JWT tokens, establishing a secure session. A WebSocket or long polling connection is initiated to maintain real-time communication. When sending a message, the backend processes it and forwards it to the recipient through the message broker. Messages are stored in databases and media is uploaded to cloud storage. Notifications are sent to the recipient's device, alerting them to new messages, and older messages are retrieved through REST APIs. Handling edge cases is crucial for a smooth user experience. For example, when users are offline, their messages will be stored and delivered when they reconnect. If message delivery fails, the system will automatically retry. To handle increased load, WebSocket connections will be load balanced across servers, and the message database will be shared to ensure fast access even as the system scales. Security is a top priority for the chat application. End-to-end encryption (E2EE) will be implemented using AES 256 encryption for the messages and RSA for key exchange, ensuring that no one except the sender and recipient can read the messages. OAuth and JWT tokens will be used for secure user authentication and role-based access control (RBAC). And role-based RBAC will manage user permissions. The system will also comply with data privacy regulations such as GDPR and HIPAA and ensure that data is transmitted securely over encrypted channels like HTTPS and WSS. To conclude, the chat application will be built with scalability, performance, and security in mind. By using WebSockets for real-time messaging, ensuring data privacy with end-to-end encryption, and building a robust infrastructure for handling millions of users, we will provide a seamless and secure communication platform. This design ensures that users can engage in smooth and private conversations regardless of the scale.